Welcome to the channel all. So I'm going to talk about this content examples that's free in the Unreal Marketplace. And I'm going to start with the content examples. This project is a collection of maps or levels, each one showcasing a different aspect or feature of Unreal Engine. Feel free to deconstruct or use these examples within your own Unreal projects. So if you go up here to File and Open Level, it basically has a bunch of levels on here. So in this video, I'm going to go to each one of these levels and just read what the level is. That's all this video is going to be about. If you're interested in that, you can continue, but I just wanted to let you know that's all this video is going to be about. So we're going to start with Animation Basics. Welcome to Animation Basics. Here, you can learn about the basics of character animation in Unreal Engine 5. The first room will demonstrate basic asset types and concepts, and the second room will dive deeper into the many features of animation blueprints. Every animation blueprint shown in this level can be found in content/example content/animation basics, or be browsed to by selecting a character display blueprint, selecting the skeletal mesh component in the details panel, navigating to the anim class reference in the animation category, and clicking on the browse to asset button. Animation retargeting. The animation retargeting map provides several examples on how to reuse animation between different characters, regardless of proportions and skeleton hierarchies. Through the use of translation retargeting, IK-Rig, and IK-Retargeter, the retargeting process can be done either at runtime or for offline creation of new animation assets. Audio. This map shows a variety of sound, actors, and assets and how you can apply them in your levels. Also included are examples of how to set up audio volumes for effects such as reverberations and volume control. Blueprint communication. This map provides examples of ways that blueprints can communicate with one another. Included are demonstrations of direct communication via casting, using event dispatchers, and sending data between blueprints using interfaces. Blueprint input. This map shows 3 examples of possible blueprint pawns. Each one shows how you can capture inputs from the player and use them in different ways to drive various blueprints. Try each one of these mini games for yourself. Blueprint mouse input. This example shows how you can use mouse inputs to control your game. The key is to set up your player controller to enable mouse clicks. Click plus hold left mouse button to drag spears. Press left mouse button to stop and start the moving cube. Blueprint splines. The blueprint splines content examples show how you can use spline components with blueprints to create paths that can be used in a number of different ways. By simply adding a spline component to your blueprint and selecting an instance of that blueprint, you will gain access to editing splines within your level. Blueprint and render targets. This map shows examples of using blueprint render to texture to implement a simple texture creator, a height field painter, and a more complex GPU fluid surface simulation. Blueprints Advanced. This map covers some useful tricks and techniques for using blueprint in your levels. Included are some randomization examples, creation of object arrays, as well as gameplay behavior such as tracking spotlights and working doors. Blueprint Overview. This map is a basic introduction to the key concepts behind blueprint visual scripting in Unreal Engine. The examples shown here are rudimentary but demonstrate fundamental principles that those new to the system must understand before using Blueprint. Effects. This map serves as a high-level overview of some of the effects possible with Cascade, the particle editing system in Unreal Engine 4. For more examples, please look at the particle effects example in the Learn tab of the launcher. Particles Intro. Examples of different emitter types in Cascade. Chaos Destruction. Welcome to Chaos Destruction. In this level, you will find a series of kiosks whose aim is to introduce you to the foundational concepts of destruction in Unreal 5. This entry hallway offers a brief explanation of each section available for you to explore. Character Rendering. Examples of character rendering features Unreal Engine now offers. Cloth. Unreal Engine 5 supports Chaos Cloth. This map shows a section of tips and techniques to get you started using Cloth in your games. Note: Cloth can be authored using the Skeletal Mesh editor in Unreal Engine 5. Common UI. Examples using Common UI to create layered and multi-platform UIs. Control Rig. The Control Rig map provides examples on how a control rig can be used to manipulate a skeletal mesh to create dynamic animation. Control rigs can be driven through animation blueprints or by sequencer. Also shown are various control rig asset techniques, as well as layering rigs, rig sharing, and splines. Decals. Decals enable you to project materials and various material elements onto a surface. You can use them to add unique effects onto specific areas of a surface, which is highly useful for decoration and variation. FBX import options. This map shows the result of some of the key settings for importing FBX files. FBX is our primary 3D content importing path used for both static and skeletal meshes. IK Rig. The IK Rig map provides several examples on how an IK rig can pose a skeletal mesh. Through interactive solvers like Full Body IK, data can be driven with animation blueprints in order to edit the skeletal mesh's pose. Also shown are various IK rig asset techniques, as well as using IK additively with animations. Landscapes. Level Scripting. This map shows a variety of uses for blueprint scripting within your level. This can be accessed from the level blueprint option in the blueprints menu of the main toolbar above. Level Streaming. This map shows the process of level streaming and different ways to bring content into your level at runtime. Keep in mind that when playing in the editor, levels are never streamed out of memory. Be sure to use standalone if testing performance. Lighting. This map gives an overview of lights and their key properties in the engine. Included are examples of light types, light mobility, shadow settings, and more. Advanced Materials. Examples of advanced material setup. Material instances. Examples of setting up material instances. Material nodes. Description of different material inputs. Material properties. Example of different material properties. Math Hall. Functions. Basic math functions and material functions graphed using the material editor on the left side. The functions all have an example usage case on the right side of the hall. Basic Trigonometry. Learn how basic vector math can unlock an entire world of possibilities for game scripting. Make objects face the player. Use vectors to measure distances. Learn how a dot product between two vectors can be useful for many things. Learn to generate orthogonal vectors in a variety of possible usage cases. Morph targets. Examples for setting up morph target. Nav mesh. Simple navigation around obstacles. Network features. Examples showcasing blueprint networking features. Niagara Advanced. Example of nearest neighbor queries. Simulation stages. Iterative constraints. Mesh reproduction. Exporting particle data to blueprint, and more. Niagara fluids. Examples of 2D and 3D gas and liquid simulations. Shows how to set up collision objects, lighting, parented simulations, quality/performance trade-offs, and more. All the simulations shown here abide by the same principles. 1. All of the simulation logic is defined in Niagara modules and not in hidden engine code. 2. Higher resolution grids often look better but cost more. One need to be careful to analyze the performance/memory impact of using fluids. 3. 2D simulations are nearly always faster and use less memory than 3D. 4. There are many options for adding collision objects. You must run in Pi to see the simulations past this room. Currently supported on Windows DX11, DX12, and Windows/Linux Vulkan. Niagara, Unreal's next generation VFX tool. Fully programmable VFX sim with no base modular behaviors, sequencer, timeline, HLSL, expression support, and inheritance. Note: Niagara has many built-in emitter templates, which will become visible in the new emitter dialog. If Show Plugin Content and Show Engine Content are enabled in the View Options menu at the bottom right of the content browser. Paper 2D. Examples using Paper 2D plugin. Parallax Occlusion Mapping. Parallax Occlusion Mapping, POM, is a function to give texture the appearance of displacement using the pixel shader. It is similar to bump offset, but gives more accurate intersections by ray tracing through a height map. This level will demonstrate how it works as well as examples. Physical animation. Examples showing physical animation. Physics. Example of various physics properties. Introduction. Pivot Painter is a 3ds Max script which comes with Unreal Engine 4. The following examples illustrate how one can use the data it stores to create procedural animations. The demonstration models were processed ahead of time using the Per Object Painter section of the script, with the exception of the tree at the end. That specific asset uses the Hierarchy Painter feature. Documentation regarding the 3ds Max workflow is available online. Pivot Painter 2. Pivot Painter 2 is a toolset that can be used to generate complex procedural animations. It consists of a 3ds Max script and editor material functions. This map demonstrates some of the tool's use cases, but is rather limited when compared with the Pivot Painter 1 content example map. Please refer to this demo map to learn about referencing Pivot Painter 2 data inside materials, and the first map to learn about writing vertex shaders from the ground up. Pivot Painter 2 has improved the workflow in 3ds Max, data accuracy, and increased the number of output options. Please follow the documentation link for more information. Post-processing. Examples of different post-process settings. Procedural Mesh. This map demonstrates various features of the procedural mesh component. Skin rendering. Examples of surface skin material. Static meshes. UMG. Examples using UMG to create in-game UI. Volumes. Examples of different volume brushes.